Good morning, everyone. I am Jyoti B, a lecturer in Chemical Engineering Department in SJ Government Polytechnic. We were learning about the instrumentation and the process control in chemical engineering subject, which is a subject of fifth semester of Unit 1 under the topic of process variables and temperature pressure measuring instruments. So, in continuation with the same subject, in the last session we have learned about the pressure measuring devices. So, we have learned what is pressure, what are the different types of pressure measuring instruments, and what are the different classification of the pressure measuring instruments, and also different types of pressures. If you would have remember, what are the different types of pressures? The pressures such as gauge pressure, absolute pressure, vacuum pressure. The classification of the various pressures also we have learned. And also the classification of the various pressure measuring devices or the equipments also we have learned. In that we have learned in the last class about the burden pressure gauge for the measurement of the pressure. So what the burden, it consists of a circular tube. The one end is fixed and the other end is free to move. The free end of the burden tube is being connected to the pointer, and the pointer in turn moves on to the calibrated scale. So one end of the burden tube we are applying the pressure, whose pressure has to be measured. So by the change in the pressure, the burden tube either coils or uncoils. As the burden tube is connected to the pointer by coiling or uncoiling of the burden tube causes the pointer to move on to the pressure on the calibrated scale. So thereby we can measure the pressure. So by having this knowledge of the pressure and the types of pressure and different types of the pressure measuring instrument, and also having a knowledge of the burden pressure gauge, we will learn in this session about the diaphragm pressure and bellows pressure transducers. So what is the principle about the diaphragm pressure gauge and the bellows pressure gauge, and also the construction and the working, how exactly it works and what is the construction, and what are the advantages and disadvantages behind using these diaphragm pressure gauges in various applications. So having all the knowledge of the diaphragm pressure and the bellows pressure gauge, we also look into some of the multiple choice questions at the end of this session. So this is how the diaphragm pressure transducer look like. So in this you have two categories of two different types of the diaphragm. So based on the material which it has made up of. So one is the metallic diaphragm, the other is the stacked diaphragm gauge. So just observe the diagram. So you'll get an idea. So how exactly you imagine how exactly the diagram, how exactly the instrument looks like by looking at these two diagrams. ನೀವು ಕೇರ್ಫುಲ್ ಆಗಿ ಇಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. ಎಲ್ಲಿ ನಾವು ಯಾವುದನ್ನ ಮೆಷರ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಇಲ್ಲಿ ಪ್ರೆಷರ್ನ ಮೆಷರ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ಪ್ರೆಷರ್ ಇಸ್ ಬೀನ್ ಎಲ್ಲಿ ಅಡ್ಮಿಟ್ ಮಾಡ್ತಾ ಇದೀವಿ, ವೇರ್ ವಿ ಆರ್ ಸೆಂಡಿಂಗ್ ದ ಪ್ರೆಷರ್ ಇನ್ ಆರ್ಡರ್ ಟು ಮೆಷರ್ ದ ಪ್ರೆಷರ್ ವಿಚ್ ಹ್ಯಾಸ್ ಬೀನ್ ಅಡ್ಮಿಟೆಡ್ ಇನ್ ಟು ದ ಎಕ್ವಿಪ್ಮೆಂಟ್. So how the diaphragm looks like also you have to observe. Just observe the diagram carefully. So before going to the learning about what diaphragm exactly is or how exactly the construction of the diaphragm pressure transducers and the working of the diaphragm pressure transducers, we have to think of what is diaphragm exactly. So do you have any idea about the diaphragm? The diaphragm is a flexible material, we can say, and it is usually made up of a rubber and usually they are referred as elastomers. So usually they are made up of a metal, the metal which is usually ductile in nature, which can be made into wires, and it is a flexible material. The flexible material may be a wire, so the metal which can be made into ductile, and usually it is a rubber material and it is used in most of the control valves, regulators, and the temperature controllers, and also in most oil and the gas control equipment. The diaphragms are mostly used in order to control the flow rate, and also to regulate the flow rate, and also to control the temperature of a particular equipment, and also in order to control the flow rate of the oil and the gas in most of the equipments. So that is about what is diaphragm. So now we have got idea what is diaphragm. So looking into the diaphragm, you can observe you have a case in which you have a metal diaphragm. So the metal diaphragm, so one end of it, or the one side or the left side of the diaphragm, the metallic diaphragm equipment, you are admitting the pressure, whose pressure whose pressure you have to measure. So one end is free to move, the one end is free to move, the other end is fixed to the pointer with a pin ion arrangement with to the diaphragm material. So the pointer moves onto the scale, which is calibrated in terms of the pressure. So what is the principle of working of the diaphragm? So as the pressure is being admitted, due to the pressure of a particular gas, the deflection of the diaphragm takes place. So the deflection is said to be proportional to the differential pressure which we have applied onto the side of the diaphragm material. So overall, the differential pressure across the diaphragm can be measured in terms of a deflection, which moves on to the calibrated scale. So as we already have an idea of what is a diaphragm, diaphragm is we can also say the diaphragm material can look in the form of a flat or the corrugated or disc plate, as you can see in the previous diagram. Here you can see in the form of a plate. Here it can be corrugated. You have a diaphragm material in the form of a corrugations. Corrugations ಅಂದ್ರೆ ನೀವು ಶೀಟ್ ಮನೆ ಮೇಲೆ ಶೀಟ್ ಹಾಕಿ ಮನೆ ಕಟ್ತಾರಲ್ಲ, ಅದು ಅಪ್ಸ್ ಅಂಡ್ ಡೌನ್ಸ್ ಇರುತ್ತಲ್ಲ, ಅದನ್ನ ನಾವು ಕೊರುಗೇಷನ್ಸ್ ಅಂತ ಹೇಳಬಹುದು. Are you getting it? So that we can tell the corrugation is, or the diaphragm material can also be in the form of a circular flat disc also. So and it is usually made up of the material called the bronze or the brass. So here in the construction you can look, the diaphragm material is always connected with a pointer mechanism which moves onto the scale. So here also you can see in the stacked diaphragm gauge, the diaphragm material is in turn connected to the pointer which moves on to the pressure scale. So the movement of the diaphragm is opposed by the spring. So we call it as a resisting spring. So here you can see in a stacked diaphragm gauge, so at the one end of the diaphragm equipment you can admit the pressure, whose pressure you want to, you can admit the fluid which is in the form of a gas or vapor, whose pressure you have to measure. It is being admitted here. So the pointer mechanism. So the force of the pressure against the effective area of the diaphragm causes a deflection of the diaphragm. So the deflection of the diaphragm causes in turn the pointer to move onto the calibrated scale. So that is in a metallic diaphragm. So in the stacked diaphragm, as you can see in a diagram, diagram here. So it is a quite large in cross-sectional area as compared to the metallic diaphragm. So usually it is usually made up of a rubber or other any flexible material. So any change in the pressure will cause the movement of the diaphragm. So the movement of the deflection of the diaphragm causes the pointer to move onto the scale. This is how it works. You can see in the diagram. So the flexible material here, you can see it is a diaphragm, the material. As the pressure is being applied at one end, it causes the diaphragm to move. So as it is connected to the pointer mechanism, pin ion, rack pin ion arrangement, the pointer moves onto the calibrated scale here, which is in the form of a circular in cross section, which shows the pressure of the applied gas or any thing whose pressure you want to measure. You can observe. I think you've got an idea how it exactly works. Here in this case, the metallic diaphragm, as the pressure is being applied, see this diaphragm material, either it contracts or expands. Either it compresses or expands due to the pressure applied at one end, so that by the contraction expansion of this diaphragm material causes the pointer to move onto the calibrated scale. I think now we have understood what exactly the diaphragm is. This is how it works. The animated video of diaphragm pressure gauge. So what are the advantages of using this diaphragm material for measuring the where it is being applied in order to control the flow rate in the control valves or in regulators, or to control the temperature in the temperature controllers, and also it is being applied in most oil and gas control equipments. So because of its good reliability and available in small sizes, and also available in the cost is also very the moderate cost. You can get it. It is affordable price. You can get it in affordable price, and can be used for the absolute and the differential pressures. So because of these advantages, it is being used in various applications, whether in order to control, whether maybe it is in the controlling the flow rate in the control valves, or into regulate in a regulators, or in a temperature controllers, or in a most oil and the gas control equipment. So as the material is being used, it has got advantages and disadvantages. ಯಾವುದೋ ಒಂದು ಮೆಟೀರಿಯಲ್ ಅಂತಂದರೆ it may not be perfect in all its working or the material of construction. ಒಂದು ಅಡ್ವಾಂಟೇಜಸ್ ಇರುತ್ತೆ, ಒಂದು ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್ ಇರುತ್ತೆ. ಸೊ ಏನು ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್ ಅಂದರೆ it is difficult to repair, and lack of good vibration, the shock resistance. It cannot resist a higher pressure range, and so it is being limited to a relatively low pressure. So moving on to the next the equipment, which is a Bellow's pressure gauge. It is also used for measuring the absolute pressure. So you can observe the diagram. First, you just observe the diagram. You have a bellows. You have a spring. This is a bellows. The pressure is being admitted here. The gas pressure, whatever whose pressure you want to measure, is being admitted at the bottom of the bellows gauge. And this is a case. Inside the case you have a bellows. The movement of the bellows is being opposed by the spring movement, and the bellows is being in turn connected to the rack and pin ion arrangement, which is connected to the pointer. The pointer moves onto the scale. So the construction, you would have observed that as compared with the burden pressure gauge or the diaphragm pressure gauge, the bellows pressure gauge also appears in the construction part. So here you can see this is a differential pressure gauge to the right side of yours. So you have two bellows here placed opposite to each other. So two bellows are being connected with a rack and pin ion movement, the gauge movement, which in turn connected to the pointer, and the pointer moves onto the scale. ನೋಡಿ ಫಿಗರ್ನ ಸರಿಯಾಗಿ ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ ನಿಮಗೆ ಒಂದು ಐಡಿಯಾ ಬರುತ್ತೆ ಯಾವ ಥರ ಇದು ವರ್ಕ್ ಆಗುತ್ತೆ. ಸೊ ಅಂಡ್ ಯು ಕ್ಯಾನ್ ಇಮ್ಯಾಜಿನ್ ದ equipment in your diagram by analyzing the diagram, the schematic diagram which is being shown here. ಸೊ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ಮೇಲೆ ಬೆಲ್ಲೋಸ್ ಅಂದರೆ ಏನು, ಆ್ಯಕ್ಚುಲಿ ಹೇಗೆ ವರ್ಕ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನು ನೀವು You have to think. Anybody has got an idea what bellows is? So usually the bellows are the thin-walled metallic cylinders. Okay, these are thin-walled metallic cylinders with one end sealed and other end is free to move. The one end is being sealed and the other end is being free to move. Here you can see the one end is being sealed and the other end is being free to move. That movement is being connected with a spring arrangement with a connecting link to the pin ion sector pin ion gear to the pointer arrangement. As I said, bellows are the thin-walled cylinder, the metallic cylinders with one end sealed and other end remains open. So usually the closed end can move freely and the open end is fixed. The closed end is moved freely and the open end is fixed. The pressure is usually applied at the open end and the bellows will be compressed. Open end ಅಲ್ಲಿ ಯಾವಾಗಲೂ pressure apply ಮಾಡ್ತೀವಿ. By applying the pressure, the bellows will be compressed. So that is about what bellows is. So principle of working is here also say it works on the same principle as the diaphragm bellows pressure gauge. Due to the application of the pressure, there will be a deflection in the pointer arrangement by the compression of the bellows on application of the pressure at the free end. So bellows, what is bellows? Bellows is an elastic element or the flexible material or the thin-walled metallic cylinder, you can say, with a flexible elastic element which gets deflected at the free end when the pressure is fed to the fixed end. The free end deflection can be taken as a measure of the pressure inside it. So usually the bellows are made up of very high strength metal, which is usually of alloy, which is ductile in nature and retains, as it is made up of an alloy, it has a high strength and retains its property after a long period of usage also. So usually the bellows pressure gauge is made up of the two types of the material, the highly ductile material. So, and there are two types of the bellows pressure gauge, the bellows pressure element and the differential pressure gauge. As you have seen in this is the bellows and this is the differential pressure gauge. So, on application of the pressure, the bellows moves and the movement of the bellows is being opposed by the spring element, you can say. And on the application of the pressure, the bellows will be either will be contracted, and the contraction is proportional to the change in the pressure that can be indicated by the movement of the pointer onto the scale. Are you getting it? So the differential pressure gauge this is about this. When the pressure is being applied, this causes the bellows to compress. So as the bellows with the application of the pressure, the bellows contract. So the contraction of the bellows causes the pointer to move on to the differential or move on to the scale, which is being calibrated in terms of the pressure. So the movement of the bellows on application of the pressure is opposed by the spring. So this is the bellows pressure gauge. In the differential pressure bellows pressure gauge, you can observe the two bellows here. You can see observe. So the difference in the pressure is also being input onto the either of the bellows. So the pressure is being applied from this side and this pressure is being applied from this side. So the differential pressure causes the bellows to contract. So as these two bellows are being connected in turn to the pin ion arrangement to which in turn connected the pointer moves onto the scale. So the differential pressure which is being applied onto the either side of the equipment causes the bellows causes the pointer to move onto the scale. So thereby you can read the differential pressure which is being fed at either ends of the bellow differential pressure equipment. So pressure is, as we have already learned, that the pressure is being applied in the differential pressure gauge on both the sides, and the differential changes will be observed by the suitable linking, as you already know, the suitable linking and the calibration of the scale. So indicated by the differential pressure, which is being indicated by the pointer movement onto the scale. So what are the advantages? So advantages is it operates in both the good and the low moderate temperature range, and it is suitable for both absolute and differential pressure measurement, and it is also can be used for the high pressure force. What are the disadvantages? So the pressure has got some the energy in it. The ambient temperature compensation is being needed while measurement of the pressure on application. So limited availability of the metal to design, because they start to be ductile in nature and also the flexible in nature. So an application of the pressure, the metals has to withstand that the corrosivity or itself, or so ಏನು ಒಂದು ಸ್ಟ್ರೆಂತ್ ಹೈ ಸ್ಟ್ರೆಂತ್ ಇರಬೇಕು. ಸೊ ಹೈ ಸ್ಟ್ರೆಂತ್ ಇರೋಂಥ ನೋಡಿಕೊಂಡು ಆ ಮೆಟಲ್ಸ್ನ ಯೂಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಸೊ ವಿ ಸೇ ದ್ಯಾಟ್ ಲಿಮಿಟೆಡ್ ಅವೈಲಬಿಲಿಟಿ ಆಫ್ ದ ಮೆಟಲ್ಸ್ ಆರ್ ದೇರ್ ಟು ಡಿಸೈನ್. So an unsuitability of is zero and stiffness nature, stiff agi madakagala, because of it has to be of the flexible the material. Artha agta idya? You have to understand. So having learning about the two types of the pressure, the burden, so diaphragm pressure gauge and the bellows pressure gauge. So we will test ourselves how much we have understood. So by multiple choice questions. So first question, which of the following conversion takes place in a burden tubes? So whether it is of pressure to displacement agata, pressure to voltage agata, pressure to strain, or pressure to force. Guess ಮಾಡಿದ್ರ ಆನ್ಸರು. So as we have learnt the same principle of operation in all, whether it is in burden pressure gauge or the bellows pressure gauge or the diaphragm pressure gauge, the principle of operation is what? Pressure to the deflection or the displacement. So the answer is, solution to this question is what? The pressure to displacements. So the capsule are made from diaphragms. True. Capsules are made from diaphragm. You will be learning in detail about the capsule in your next class session. The third question for you is, which of the following devices convert pressure to displacement? Whether diaphragm, bellows, capsule, or both diaphragm and the capsule. What is your answer? Both diaphragm and capsule. So bellows gauges are used for measuring the pressure. So the range of measuring the pressures to remember is also very important. Remembrance of the range of pressure measurement is also very important. So I have given this as a list in your study material. You can go through that. The bellows gauges are used for measuring the pressure. What? Below, whether it is below 2 what? Pounds per square inch, or above 5 pounds per square inch, or above 3 pounds per square inch, or below 3 pounds per square inch. The answer is below 3 psi. So diaphragm pressure gauge can detect the pressure difference even in the range of whether it is 0 to 4 mm or 0 to 10 mm or 0 to 2 mm or 0 to 7 mm. The answer is 0 to 4 mm. The stacked diaphragm gauge can measure over the pressure ranges as low as -mm of Hg. just observe the answers, and you have to remember the range of pressure measurement. The solution is C. So Bellow's type gauges are used for the measurement of what pressure I've been told you. So whether it's an absolute pressure, atmospheric pressure, the vacuum pressure, and none of these. So all these, the definition of the different types of the pressure should be in your tongue, tip of the mouth. So it is absolute pressure. So I hope you have benefited from this session and it is understandable to you. The explanation point of understanding. So for more detailed detailed reference, I've given the study material also for this session, and you can go through the study material, and also you can have a reference of these these books which have been given. For the proper animated video also, the link is also been given. You can log into this link, and you can thoroughly understand how exactly the different pressure gauges can measure. So the books you can refer, as I've been telling from my first sessions. You have to have a book by Instrumentation and the Process Control by A.P. Culinary, which is a very good book which has been opted for the final year diploma students for the subject Instrumentation and Process Control. And you can, for the extra reference, you can refer the Process Control by Harriet and Instrumentation and Process Control by R.P. Vyas, Instrumental Methods of Chemical Analysis by B.K. Sharma. So books refer ಮಾಡೋದ್ರಿಂದ you will get an idea what exactly the different instruments and you'll get a vast idea by reading a book instead of reading only the study material which has been given by your teacher. So it's better to refer the different books which are available for the particular subject. I hope you have all understood by this session and benefited by this session. Thank you all.